All right, let's look at the homework 12.4, problem number 6. All right. All right, so we have 3 points, P, Q, and R, and we want to find the vector orthogonal to the plane through the points P, Q, and R. All right, so we have a plane, so like that, and this guy contains all 3 points. Say I'm gonna put say P here and maybe Q here and R here. All right, so what we want to do is we want to find the vector orthogonal to the plane. So what we can do is we can maybe create a vector from P to Q and P to R. Then we know that the vector cross product is a vector. So it's going to be PQ, vector PQ cross product with vector PR is going to be perpendicular to both of these vectors, right? All right, so let's find PQ first. Vector PQ. All right, so this is going to be simply it's a subtraction, right? So 0 minus negative 1, so it's going to be positive 1. 6 minus 4 is 2. And 3 minus 1 is 2. All right, so that's PQ. And then we need a PR. So let's find that. PR is going to be 4 minus negative 1, so it's going to be positive 5. And 3 minus 4 is negative 1. And negative 1 minus 1, so it's going to be negative 2. All right, so let's take the cross product. So actually I want the PQ. So we're going to have PQ cross product with vector PR. Right, so this is going to be, so it's a determinant I, J, K, and 1, 2, 2, and 5, negative 1, negative 2. All right, so this is going to be, first component would be 2 times negative 2 is negative 4, and a minus negative 2, so it's going to be plus 2. All right, minus, right, 1 times negative 2 is negative 2, minus 2 times 5 is 10. All right, and the last one is 1 times 1 is negative 1, minus 2 times 5 is going to be 10. All right, so this is going to be, let's see, negative 2, comma, positive 12, comma, negative 11. All right, so let's type that in. All right, so you have here, it's going to be vector negative 2, positive 12, negative 11. All right, so let's submit for testing. All right, it came back and looks like we got the part A correctly. So let's look at part B. We want to find the area of the triangle PQR. All right, so let's do that. So we are basically connecting R and Q together, and we have this region right here. Right, so that's the region we are interested in, right? But remember that the magnitude of the cross product is the area of the parallelogram. So we're actually getting a little bit more than we want. So you're actually getting twice as much, right? Because a parallelogram would look like that. And the area of the triangle is simply a half of that, right? So the area A, so this is going to be for part B, and this was for part A. Right, so the area A is going to be 1/2 of the magnitude of the cross product of PQ and the vector PR. Right, so this is going to be 1/2. Right, then this is a square root of, right, so this is -2 squared, so that's 4, plus 12 squared would be 144, I believe. 144. And -11 squared would be 121. So this is going to be square root of, let's see, so 4 plus, so it's going to 148. So 148 plus 121 would be 8 plus 1 is 9. 4 times 2 is 6. And 1 plus 1 is 2. Right? Over 2. Right? Not sure this can be simplified. So I'm going to just go ahead and type it into square root of 269 over 2. Right? So I'm going to put square root of 269 over 2. All right, let's just go ahead and check the answer. All right, submit for testing. All right, I came back and looks like we got this one correctly as well. All right, that's it. I hope that this was clear.